Okay, this question is asking us to identify the pre-image coordinates, which I already have, 2, 6, 5, 6, and 1, 1, and this is the yellow triangle. And it's asking us to rotate it about the origin 90 degrees clockwise to form triangle A prime, B prime, C prime. Now, outside of memorizing the different rules for rotations, another way to be able to perform this is literally take your paper and turn it to the left 90 degrees and look at the points A, B, and C now as if the new top of your paper was the top. So point A appears to be negative 6, 2. Point B appears to be point negative 6, 5. And point C appears to be the point negative 1, 1. And then if I put my paper back the original way, I can now plot the points negative 6, 2, negative 6, 5, and negative 1, 1, which I determined when I had turned my paper, plot them the regular way, and you will have rotated the original figure 90 degrees clockwise. And there is, in fact, triangle A prime, B prime, C prime, which appears to have been rotated clockwise 90 degrees. So now I'll attempt the exact same thing, again on this time triangle DEF, and my intent is to rotate it 90 degrees clockwise by turning my paper left and reading the coordinates as if the new top of the paper was up. So it appears to me that D is now located at 2, negative 7, E is now located at 3, negative 2, and F at 7, negative 2. Remembering those numbers, I turn my paper back, and I write down my points and plot my new triangle, and it does in fact appear to have been rotated 90 degrees clockwise to form triangle D prime, E prime, F prime. Now here I'm given point A a pre-image and A prime an image, and I'm asked to find the translation rule from the pre-image to the image. In the first set of points, A to A prime, it appears that the X coordinate went down 4 while the Y coordinate went down 2. In the second one, it looks like the X went up 7 from negative 4 to 3, and that the Y went down 11 from 11 to 0. In question C, X dropped by 1 and Y increased by 5. And in question D, X increased by 3 and Y didn't change at all, so I just leave it as Y. Now here it's asked a different way. I'm given the translation rule, and then I'm provided a pre-image, and then an image. And sometimes I'm given the pre-image and asked to find the image, like question A, and B, and D. And sometimes I'm given the pre-image and asked to find the image. I just said the same thing twice. And sometimes you're asked to find the pre-image given the image. So you kind of have to look at the rule and decide where are you starting and where are you finishing. So in question A, I'm starting at negative 4, 7, and I'm adding 3 to X and subtracting 5 to Y, which gives me negative 1, 2. In question B, I'm starting at 9, 1, I'm dropping the X by 7 and the Y by 1, leaving me at 2, 0. But in question C, I'm wondering where I started, because after adding 1 to X and 6 to Y, I landed at 4, negative 1, which means I must have started at 3, negative 7. In question D, I'm back to starting at 8, negative 4. I do not change X, but I add 4 to Y, landing at 8, 0. And for the final two questions, again, I've landed somewhere. I'm given a rule and I have to work backwards. So if I added 3 to X and I added 1 to Y, and I landed at 4, negative 1, I must have started at negative 7, 0. And in the last problem, if I subtracted 8 from X and subtracted 5 from Y, and I landed at negative 3, I must have started at 5, 2. Finally here, there's just a slightly different notation with vectors. Negative 5, 2, 0, negative 12, and negative 1.5, negative 7. And they translate into coordinate form just the same as before. You're either adding or subtracting from the X coordinate or adding or subtracting from the Y coordinate. And because of the need for a compass and a straight edge to do these rigid motion constructions, we're going to have a separate video for this and this slide, and we'll pick up right here, back on the grid. Okay, what we had previously talked about as a sequence of rigid motions off the coordinate grid is really what we used to call composite transformations on the grid, which basically means multiple steps, multiple transformations done to the same pre-image. So what we're starting with here is triangle ABC, which you see plotted below, and you work backwards. The first thing you do, it's very similar to function notation, you do whatever's closest to it first, and you actually work right to left. So the first thing we'll do is reflect it over the y-axis, then we'll take that new shape, that image, and then translate it -3, 5. So that's my first step. I reflected it over the y-axis, and I will now take this new triangle and I will translate that one to the left 3 and up 5 for the final step. So I will take each point and go to the left 3 and up 5. Just like that. Connect them and I have my A prime, B prime, C prime. And that's a composite transformation, remembering to work right to left. The second example is much the same. I'm going to rotate, because that's the first thing I see, right to left, clockwise, about the origin 90 degrees, and then after I've done that, I'll take the new shape and reflect it over the x-axis for the final answer. Now remember how we rotated in the last section? I actually turned my paper and looked at the points, and it appears that A is at -8, 1, it appears that B is at -7, 4, and it appears that C is at -3, 1. I'll turn my paper back and plot those points. And after I plot those points, I now have a rotation of 90 clockwise about the origin, and now I'll reflect it over the x-axis. And after that second step, I have my final composite transformation of A prime, B prime, C prime. Now to tie all this together, meaning congruence and rigid motions together, we were going to name a series of rigid motions, or really a composite transformation off the coordinate grid, which maps ABC, which is this original triangle, onto ultimately A prime, B prime, C prime, which is way over there, through a series of steps. Now if you were asked to do this, this line DE may or may not be provided. Don't be afraid to draw in your own auxiliary lines. DE in this case is what it was named, because what I'm going to have to do is reflect ABC over that line. Now that line is really the perpendicular bisector between C and C prime. Once I reflect over that, I now have this shape here. Now because I'm ultimately going to rotate about point A, I'm actually going to translate along this vector rather than this one here. They're really the same translation, but I think it's easier to see if we translate along this one here. So I'm going to translate A prime such that it maps onto a triple prime, which then gives me this shape right here. I'm getting closer now to getting that original triangle mapped onto A triple prime, B triple prime, C triple prime. I have one more step, but now that my A's are lined up, I'm going to rotate about point A such that point B double prime maps on to point B triple prime. And then I'm finally done. I've started with my original triangle, and through a series of steps, I was able to map it onto this triangle here. Very important to know for the Common Core.